Okay, so if you still have trouble with the homework, okay, you can ask me after the class, right? Kind of running out of space here, right? Can you raise your hand if you are on this page, okay? Please raise your hand. Everyone's ready? Angela and Chris? Okay, right, so last time we find the angles in domain. We'll just look at question A for now, okay? Angles in domain, that's in the, I've highlighted, okay, right here. Right, angles in domain. So there's another part of the answer that's called the general solution. If you look at the instruction, solve for x in the domain, right? That's the first part. And then find general solution. So that's second part. Okay, so we're gonna look at second part. General solution means if the domain is unlimited, okay, they don't give you a restriction on it. It can be anything. So we want to find the answer that is for the whole real number. That's why it says general solution over real numbers. Okay. So that means if you look at question 8 now, right? The picture's the same. Okay, I'm gonna erase a little bit. Okay. Erase this part. Okay, so it's more clean, right? So we same quadrant, right? Quadrant 3, quadrant 4. Okay, I'm just redrawing it. We start with quadrant 3. Okay, so this is what we got first, and that angle is 7 pi over 6, right? That's one of the angle we got. So general solution means if I want to keep on getting to the same place. For example, if I want to get to here, quadrant 3, all I need to do is just to make one more turn. I will still get to the same quadrant 3, right? So making one more turn is like adding a 2 pi. 2 pi is like 360 degrees, right? One circle. So if you add a 2 pi, you get back to the same place. You get the same ratios, okay? So add another 2 pi, right? That angle will also give you the same ratios. Or you could subtract 2 pi, right? So it's always by multiple of 2 pi. You always add a circle, then you get to the same place. Okay, then you can have infinite number of angles that will always have the same ratio of -half, right? Ratio is -half. So the general solution, if it's in quadrant 3, okay, we'll write it down here. Okay. Okay, I'll put it down here. Okay, general solution. Okay, it will be x equal to 7 pi over 6. Okay, plus 2 pi n. 2 pi means a circle, right? A complete circle. N is the number of times that you turn. Okay, so that's for quadrant 3. Any questions so far? Can you raise your hand if you understand why we added 2 pi n here? Adding the 2 pi n is to represent all the angle that can stop there, okay? So for example, 7 pi over 6 is the first one, right? This one. Okay, if I add a 2 pi, okay, get a common denominator, 7 pi over 6 plus, that will be 12 pi over 6, right? That's 2 pi. is 19 pi over 6. So 19 pi over 6 will be this one. Okay, it will still stop there. Okay, if you add another 12 pi over 6, right, add another circle, that will be 31 pi over 6. Okay, 7 pi over 6, 19 pi over 6, 31 pi over 6, and so on, right? You can keep on adding 12 pi over 6. It will all have the same ratios. Okay, so that's why it's called a general solution. Right, so we can do the same thing for quadrant 4. Okay, so quadrant 4 means it will stop here. So our first angle, okay, how big is the first answer? Okay, let's ask some of you, okay? The first turn, right, the first time it hits here, how big is that angle? Chris?
5 pi over 6.
Can you say that one more time?
You said 5 pi over 6?
No, no, in the fourth quadrant.
Oh,
Let's
sure.
Hmm?
I'm not sure.
Last week, right, we have two answers, right? One is 7 pi over 6. What's the other one? Do you see inside the red box? We
11
have
pi over 6.
Can you say that again?
Is it 11 pi over 6?
Yeah, that's the second answer. That's in quadrant 4, okay? So that's 11 pi over 6. Now, if I add 2 pi, that means I make another circle. It will stop at the same place, okay? How big is that angle then? Daniel?
Wait, can you ask the question again?
Yeah, if I add another 2 pi to this same angle, what's the angle? Did you get my question?
Yeah, 23 pi over 6.
That's right, okay? You just add a fraction, right? 11 pi over 6 plus 12 pi over 6, right? Get a common denominator. All right, so you get 23 pi over 6. So that will be the second answer, okay? You can keep on adding, add another 2 pi. So next one will be 35 pi over 6, and so on, okay? So to represent all the answer there, then you just add 2 pi n, okay? So the second one is 11 pi over 6 plus 2 pi n. So this is called the general solution, okay? So let's box that. So you always add 2 pi n, okay, to get to the all the answer, okay, to represent all the answers there. Okay, I'll put the original picture back. Opposite hypotenuse, opposite. Okay. Any questions so far to get the general solutions? Okay, so for example, let's look at, okay, the bottom one, right? Question C. So the one you see in the box, this is called angles in domain, right? These are in the domain. Domain is 0 to 2 pi, okay? Now I would like you to try and write down the general solution. Okay, so it'll be x equal to what? So please write down the general solutions, all right? And then raise your hand. So you look at your pictures, right? You have the one arm that's there, the red arm, okay? Do you see that red arm? And then the other one for the right side, you have this one. Okay, very simple. General solution, don't think of it as like a very complicated thing, okay? All you need to do is just add 2 pi n, because it takes a full circle to get back to the same place. So you just add 2 pi n to your original angle, okay?
Jason,
Yep.
could you repeat how we find n?
N you don't need to find. N represents integers, number of terms. So n could be 1, 2, 3, 4. Okay, could be -1, -2, right? Could be 0.
Okay.
Yeah, so when n equals to 1, it just means it makes one turn. Okay, n equal 2 makes 2 turns.
Okay, thank you.
Okay, Marcus, what's the first general solution?
Wait, wait. Isn't it just 5 pi over 2? Let's just add 2 pi to 3 pi over 2.
Hmm?
Wait,
What's the beginning angle?
pi over 6,
Pi over 6, yeah. Pi over 6, and then you add
2 pi,
2 pi n.
n.
Okay, the n represents it can make multiple turns. Okay, if you only write 2 pi, it means only add one turn, right? But you want to represent in general. General means represent all the answers, not just the first answer or second answer. Okay, so that's why you write the n. Okay. Okay, Angela, what about the second answer? The second general?
5 pi over 6 plus 2 pi n.
Yep. Right, and Philip, third one?
3 pi over 2 plus 2 pi n.
Yeah. Okay, if you finish, can you raise your hand? So remember, n cannot be decimals, right? Because n represents number of turns. It has to make a full turn to get to the same place. Okay, so at the end, you need to add one more thing. N is, okay, this symbol represent is integers. So I for integers, okay? So remember, you have to always add the last part as part of your answer, okay? So at school, they take little marks off, okay? If you forgot the n is integers. Okay, this means n is integers. So when n equals to 0, then it tells you the angles in the domain. Right? When n equal to 0, then 2 pi is gone, right? It means it's not making any turn. When n equal to 1, it finds the next answer. N equals to 2 finds another answer, right? That's why it's called a general solutions. Okay, if you finish writing it down, please raise your hand. Okay, Evan and Marcus, Jocelyn. Okay, so looks like if you have 3 answers, right, in the domain, then you would have 3 general solutions, right? Each one of them, you add the 2 pi and you get general. If you look at the next question, okay, question D. How many general solutions do you think we will have? Susan? How many general solutions do you think we need for question D?
3.
Why? Why 3?
4.
Why 4?
Because you can add 2 pi n to all of them.
Yes, okay, because original we have 0, pi, power 3, 5 power 3, right? You have 4 of them, right? 1, 2, 3, 4. So normally, right, we would just add 2 pi n to each one, and then we will get 4 general solutions. It's not wrong, okay? But if it's possible to simplify your solution, we always do that, okay? So at school, they will expect you to write a simplified way, okay? So how do I know this one I can simplify? So if you look at the arms, for the angles in the domain, okay? So everyone please pay attention here, right? Angles in domain. The first answer of the angle in domain is 0, right? 0, the arm is over here. You see, I draw the red, right? And what is the second answer in domain? Waylon? What is the second answer in domain?
Pi.
Yeah, so pi is on the left side, right? You see the arm now? Now, because those 2 arms, they make a straight line, then you could do some simplifying so you don't need to add 2 pi, okay? From one answer to the next answer, all I need is to add a pi because they are pi apart. 0 plus pi give you pi. Pi plus another pi give you back to the first arm, right? You add another pi, give you the next one. Add a pi, it give you the next one. So you could just add multiples of pi, and that will include both arms. Okay? Adding 2 pi n, it only gets back to the same place, right? Let me compare the two, right? If I do 2 pi n, it will go 1, right? That's 2 pi n. Another one, right? But then it's always missing the left side. But if I just add pi each time, add a pi, I'll get to the left side. Add a pi, I get to the right side. Add a pi, I get to the left. Add another pi, get to the right. It will cover both answers at the same time. Okay, so for 0 and pi, because they make a straight line, then your general solution, you just need to have 0 plus pi n. That will include 0 and pi. Okay, because they form straight line. But 0 is not like nothing, right? So you could just write pi n like that. Okay, so pi n will include both sides. Okay, whenever you can simplify, you always do that. Okay, can you raise your hand if you understand why we add pi n instead of 2 pi n for this one? Okay, do you still have questions? Eric, Jocelyn, and Marcus? Okay, we add pi n because the two arms, they make straight lines. Okay, if they don't have straight lines, for example, like the right hand side now, right? One arm is in the first quadrant, the other arm is the fourth quadrant, right? They don't make straight lines, then you need to use 2 pi n. You get power 3 plus 2 pi n, 5 power 3 plus 2 pi n. Okay? Because they don't make straight lines. You cannot simplify it. Okay, what are we missing here? Nick? What else are we missing?
I'm not sure.
Think about it. I mentioned it in question C. We always need to put what at the end?
The integer.
Yes, okay. Make sure you remember to write n is integer. Okay? So this is for general solution. How you go from domain, angles in domain, and then turn it into general solution. Okay, so make a little note. Okay. Oh, I'm running out of space. Okay, so find a space. I'll just add in here. Okay. Two arms. Okay. Two arms. Make a straight line. Okay. So that's why it uses pi n. All right, so let's have a break. Okay, we'll continue. Okay, after the break at 11:20. Okay.